Hi, this is your phone, and it's dead. This is the time of electricity. No power, no communications. Phones, tablets, laptops, and other equipments that are feeding on electricity are everywhere to be found. But it's really their batteries that are supporting your work in silence, playing a critical role in every aspect. And that is what we are analyzing and showing you today.
Apparently that battery is a type of power source with galvanic cells connected in series. There can be multiple cells in the battery. A battery's voltage equals to the sum of each cell's potential difference. There are two kinds of cells in the battery system. One is primary and the other one is secondary. For primary cells, they are neither rechargeable nor reversible. However, for secondary cells, they can generally be recharged and work reversely. There had been multiple generations of batteries since its invention. In 1800, Alessandro Volta saw the cramps when someone puts two metal pieces on a frog's leg. Others argued it as a type of presence of bioelectricity, while Volta found it was actually the potential difference between two different metals that caused the shaking of the leg. Inspired by this particular phenomenon, he was then able to invent the first battery in human history, the voltaic pipe. In a single cell of a typical voltaic pipe, there is a piece of electrolyte between each zinc and the copper plate. By putting multiple cells together, an ideal voltage is generated. But what is actually going on in such a cell? At the cathode, it goes reduction reaction. Hydroanion with electrons produces hydrogen. At the anode, there is an oxidation reaction that turns zinc to zinc cation and thus releases electrons. Voltaic pipe lies a milestone in the history of battery. Later batteries are generally based on the similar principle of it. They are more stable in electrical currents and are both rechargeable and portable, with efficient materials such as dry electrolyte. Then in 1859, Castan Plantin, a French physicist, invented the first lead storage battery, known as Plantin battery. In this type of battery, it contains lead and lead dioxide in sulfuric acid solution. Its physical properties made it to be the first rechargeable battery in the world. When we are using the power inside the lead storage battery, the chemical reaction goes like this: lead dioxide, hydrogen ion, sulfuric acid are turned into lead sulfate and water. When we are charging such a battery from a power source, the chemical reaction just happens in the reversed way. Lead sulfate and water are turned into lead dioxide, hydrogen ion, and sulfuric acid. This is a lead storage battery, which contains 6 2-volt cells connected in series. It has a total potential difference of 12 volts. According to the equation of net voltage we've mentioned before, this is one of the most ancient batteries that people are still using today. If you wonder where it is, just pop the hood of a car. The lead storage batteries are widely served as the power source for engine starting. The reason is that such batteries fit most vehicles. It can function for several years and is able to undergo extreme temperature from -30 degrees to 50 degrees Celsius. Also, it is the best choice for cars, as it is very capable for constant collisions and shakes when you drive on rough roads. However, due to discharge and charge cycles, physical damage and chemical side reactions, the lifetime of a vehicle battery is usually considered to be a maximum of 5 years. Disposing lead storage batteries can cause environmental pollutions, as it contains heavy metal lead and corrosive solution, sulfuric acid. time went to 1886 when the first carbon-zinc battery is invented by a German physician Karl Gessner. It was a primary battery as it couldn't be recharged. Here you can see it contains carbon rod, zinc case, and manganese oxide, which also made it to be the first dry cell battery in the world. In a carbon-zinc dry cell, the chemical reaction goes follows. At the anode, it is zinc with chloride ions to form zinc chloride and release electrons. At the cathode, it is manganese dioxide, ammonium chloride, water, and electrons to form magnesium oxide, ammonium hydroxide, and chloride ions. It wasn't until 1901 when the idea of alkaline batteries, a type of primary battery that cannot be recharged, was firstly introduced by Thomas Edison. It contains magnesium oxide and zinc. You can consider it as an upgraded version of the carbon-zinc batteries, but the practical products wasn't designed until the 1950s by Louis Urey at Everyday Battery Company. Here is what happens in alkaline dry cells. At the cathode, it is manganese dioxide, water, electrons to form manganese oxide and hydroxide ion. At the anode, it is zinc with hydroxide ion in order to form zinc oxide, water, and electrons. Both carbon-zinc batteries and alkaline batteries are the most popular ones because we can find them in every corner of our daily life, in remote controls, clocks, and toys. I bet you must have experienced such a situation. A rotten battery lying in the remote control is really a blood pressure booster when you see this mess. Here is how it forms. Such phenomenon usually happens to carbon-zinc batteries because for carbon-zinc batteries, it has a zinc case. Such a case is both a reactant and a container. When you leave this battery in the remote control for a long time, the zinc case, which is the kind of reactant, will decrease in strongness and finally cause the corrosive liquid inside to leak. On the other hand, for the alkaline battery, it has a steel case and it is non-reactive. Such a case is designed to be durable to hold things inside. As a result, the alkaline batteries are much more suitable for remote controls. Here is a table to compare carbon-zinc batteries and alkaline batteries. The alkaline battery has a capacity 4 to 7 times larger than the carbon-zinc ones. It is a little bit more expensive, but it is actually able to provide both low and high current. Since carbon-zinc batteries contains cadmium, it requires recycling, but alkaline battery can be disposed as a daily garbage. Also, alkaline battery's case is much more stable to prevent leakage and damage. Invented in 1973, lithium-ion battery is a secondary cell and has a high complexity in internal structure. What you should remember is never try to break any lithium-ion battery because it can be explosive when the contents come into contact with air. Lithium-ion battery is widely used in cordless tools, cell phones, laptops, and even the new generation vehicles.
4.35 volts.
On the case indicates such kind of lithium-ion cell has a potential difference of
4.35 volts.
This huge icon on the right side that looks like a garbage bin tells you that it cannot be considered a daily waste. It requires harmless recycling methods. Have you ever wondered this? Since the electrical vehicles are using lithium-ion batteries for driving power supply, it makes no sense that traditional cars are still using lead storage batteries for engine starting. Here is what we find through analysis. First of all, lithium-ion batteries are generally more expensive than lead storage batteries. Secondly, lithium-ion batteries cannot bear the high temperature from the engines. Last but not the least, lithium-ion batteries requires a customized management system, but the lead storage batteries don't. These disadvantages stopped lithium-ion batteries from substituting the traditional lead batteries on cars.
What is the future of batteries? Here's an interview with Mr. Bobby.
With the high-speed development in both market needs and material engineering, graphene, the most advanced electrical material for future batteries in the 21st century, emerged in recent decades. What we have today is to apply graphene to the traditional lithium-ion battery. In the traditional lithium-ion battery, we have carbon at its cathode, and now we plan to substitute carbon with graphene. It could enhance the battery's efficiency, such as charging speed and capacity, but currently it's very expensive and difficult to build, so there is no practical merchandise in the market. Pure graphene battery is an idea developed by some material engineers, still with low maturity. We want it to be capable for storage large amounts of electrons and super fast charging speed. For example, if your phone has this brand new type of battery, it may only request a charge once an entire week.
Time is money. With the rapid need of electricity, those two factors enormously increase the demand for faster charging speed. Through our team's analysis, there are currently two main types of fast charging techniques in global market. They are high voltage low current and high current low voltage. To calculate the power, which can be seen as the speed of transferring electricity from the charger to the device itself, we would use the equation P equals to U times I, where U stands for voltage and I stands for current. This reflects the thinkings of those enterprises that we've just mentioned. You either increase the voltage or current in order to get a greater result. But due to physical limits of Li-ion batteries, the charging voltage is a fixed value. What is the purpose of increasing the voltage of charging then? The representing enterprise of high voltage low current solution is Qualcomm. This was due to the limitations of wire qualities back to 2013. At that time, most enterprises used micro-USB wires, in which with the thinness of single wires and the smallness of contacting area of the port together fix the maximum current at 2 amperes. This blocks the way of increasing the value of current. They decided to increase the value of voltage instead. This idea was similar to that used in long-distance electricity transmission. In the equation Q equals I squared RT, you want to decrease the value of I as much as possible to reduce the generation of heat. By looking at P equals to U times I, you would find that the power of charger remains stable. By increasing the voltage, you can actually reduce the current generated, same as the energy lost in terms of heat. However, by overcoming the difficulties on the wires, the voltage needs a second reduction inside the phone in order to meet the voltage of the battery, and this is the time when the presence of heat is inevitable, which is a disadvantage of this solution. However, this method greatly improved the acceptance of types of wires that is used for charging, which reduced the cost of changing existing hardware and standards. In the next few years, with the development of wire quality and rapid need for a more stable and safe charging method, micro-USB wires are generally abandoned by enterprises. Businesses gradually chose Type-C wires, which have larger cross-sectional areas of single wire and larger contacting area on both sides between the wire and your phone. These manufacturers, typically Huawei, Oppo, and OnePlus, try to move the sub-transformer out of your phone and put it inside the charger in order to prevent a second heat generation. With the help of increased capacity of current flow, they decided to increase the value of current in order to boost the efficiency. However, different manufacturers could have different types of wires for charging purposes, which actually increased the difficulty of adaptability for different phones when they face shortage of power. You will see how those two distinct solutions are actually helping improving the situation. Time, background, and limits are also playing a significant role in it, showing how this industry developed and responded to market needs throughout those years. All creations have a fixed lifespan. That applies to batteries as well. There are a huge number of factors that will lead to the degradation of batteries. Generally speaking, they can be found in process of designing, production, and applications. We'll look into design first. We all know that Li-ion batteries works by having its Li-ions moving from anodes to cathodes, and vice versa, which tells us the material chosen for anodes and cathodes can really influence its lifespan. For instance, In the research conducted by Kunming University of Technology, they found that between two often used materials for cathodes, lithium cobalt oxide and lithium manganese oxide, have great difference on the lifespan of batteries. I quote here, lithium cobalt oxide is a Li-ion intercalated compound, which means that if, during the charging process, there are too many, often over half amount of Li ions, are de-embedding from the cathode at the same time, there would be a change in the crystal structure, which no longer enables this compound from embedding and de-embedding Li ions. This is like when you take out a single pillar from a skyscraper. It would not have a lot of impacts, but taking all of them out at once would just lead to a collapse that destroyed the function of the building. However, this problem is not yet seen in lithium manganese oxide. The problem with lithium manganese oxide is that during the process of discharging, Li ions are embedded into lithium manganese oxide, and thus force Mn4+ ions to reduce into Mn3+ ions, which then gradually convert the crystal structure into a more stable one, reducing its ability of accepting and releasing Li ions. Other factors like pack design, including the physical pressure on the pack of batteries and the effect of cooling structure in the device, are also impacting the batteries. We're not going into those there. Then we move to the process of production, in which way the humidity influences the lifespan as well. The most commonly seen salt in electrolyte is lithium hexafluorophosphate. When water contacts with lithium hexafluorophosphate, they react, and one of the products is hydrofluoric acid. As we all know that this is an extremely corrosive acid, it would definitely do harm to the metal materials in the battery pack and cause leakage. Meanwhile, the SEI layer, or solid electrolyte interface layer, is a component of lithium-ion batteries, formed from the decomposition materials associated with the electrolyte of the battery. It is a naturally formed material in the Li-ion battery to prevent organic solvents from contacting cathodes and anodes and thus cause further corrosions. Can also undergo a reaction with the hydrofluoric acid, which would lead to precipitations in the form of lithium fluoride, constantly attracts and reduces the amount of active Li ions, and finally lead to early degradations of batteries. Other factors including electrolyte filling method, aging method, and formation method that are found in the process of production are also influencing the lifespan of Li-ion batteries. Last but not the least, the influence of practical applications is also a huge factor contributing to the degradation in lifespan of lithium-ion batteries. In an early research conducted by the NASA, researchers has found that the capacity decreases as the storage temperature increases, as it is shown in the presentation. Factors like charging voltage and current are also playing significant roles. However, today they can be controlled by the power management chips, in which case any informal charging behaviors can be stopped at a very early stage. It's also a crucial part in the cycle of battery life, the afterlife experience, which, in other words, the recycling methods for those that serve their lives. For traditional alkaline batteries, the first step will be disassembling the anode and cathodes, getting copper and zinc metals. Secondly, those two types of fragments will be put into strong alkaline solution. Copper will be filtrated, and then by conducting electrolysis of the solution, we can get zinc. Afterwards, potassium hydroxide will be added into the rest solution, getting potassium manganate. Through a second electrolysis, we can get potassium permanganate. For Li-ion batteries, as we find this detailed procedure for common Li-ion recycling factories, the general step is firstly opening and disassembling the battery, followed by physical separation, and lastly, material recovery. This set of recycling succeeded in getting pure lithium, plastics, anodes and cathodes, steel and iron, and other parts of original batteries, makes it less hazardous for the environment. As our society develops, there will definitely be more means of portable energy supplies emerging in the future. While those batteries are making our life much easier and of higher efficiency, we do need to consider the side effects that brings to us. Sustainability is always the thing to chase after and keep in mind along with convenience.